Hello everyone, my name is Devo Onurasmi with the name 1030123400210, and today we'll be explaining the converting to fulfill the first week assignment of digital system. Hello everyone, my name is Devo Onurasmi from IF47INT with the name 1030123400210, and today we'll be explaining to you about converting. So the first one is how to convert from decimal to binary. So the first example will be 99 with the basis of 10 because 10 is the basis of the decimal, equal to point with the basis of 2 because 2 is the basis of the binary. So the first thing that we need to do is we write the value of the decimal, which is 99, and then we will divide it. We will divide it by the basis of the binary, which is 2. So we divide it to 2, and then we will get 49 with the remains of 1, and then we divide the 49 with the basis of the binary to 2. We divide 49 to 2, and then we will get 24 with the remains of 1, and then we divide it again. 24 divided by 2 will be equal to 12 with the remains 0, and then we divide we divide 12 by 2, we will get 6 with the remains 0, and we divide 6 by 2, and then we will get 3, the remains 0, and then we divide 3 by 2, and then we will get 1 with the remains 1, and we divide 1 2, we divide 1 by 2, it will be equal to 0 with the remains of 1. So we so the top one will be the LSB, or the least significant bit, or the bit that will be go on the last one, or on the right one. So we put it 1 1 0 0 0 1 1. So the one on the most left is the MSB, or the most significant bit, while this one, the one on the most right, will be the LSB. And then this will be the end result, the basis of 2. This will be the answer, will be the binary. Going on to the second part, which is how to convert from binary to decimal. So first example is 10000111 with the basis of 2. 2, as we know, is the basis of the binary, and it will be equal to point with the basis of 10, because 10, as we know, is the basis of the decimal. So what we need to do here is we need to write the value of the binary, and then we need to times it with the basis, which is 2. So what I mean is we need to write it since the first one from the MSB, which is 1, and then we need to times it with the basis, which is 2. Then it will be plus 0 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2. But the basis, or the number 2, has a power, and you can write it from the LSB. So because the LSB will be the first one, and the power of the 2 will be 0. And then you can continue it to the left, from the LSB to the MSB, and you add the power each. If you go to the left each, you will add the power by 1. So starting from the LSB, it will be 1 times 2 with the power of 0, and then going to the left, it will be 1 times 2 with the power of 1, with the power of 2, with the power of 3, with the power of 4, with the power of 5, with the power of 6. And then what we get here is we will get 64 plus 0 plus 0 plus 0 plus 4 plus 2 plus 1, because 2 to the power of 6 to the power of 6 will be 64, and 0 times 2 to the power of 5 will be 0, plus 0 times 2 to the power of 4 will be 0, plus 0 times 2 to the power of 3 will be 0, plus 1 times 2 to the power of 2 will be 4, plus 1 times 2 to the power of 1 will be 2, plus 1 times 2 to the power of 0 will be 1. And then we will get 71 with the basis of 10, because we convert from binary to decimal, then we get the decimal, which is 71 with the basis of 10. Okay, so moving on to the third part, I will explain to you how to convert from decimal to hex, and this is the hexadecimal to decimal table. You need to see it because we will use it later. Okay, so the third part, which is from decimal to hexadecimal or hex. So we have, for example, is 158 with the basis of 10, because 10 is the basis of the decimal, will be equal to point with the basis of 16, because 16 is the basis of hexadecimal. Alright, so what we need to do to convert from decimal to hex, we need to divide the value of the decimal, which is 158. We need to divide it to the basis of the hexadecimal, which is 16, and then we will get 9 with the remains of 14, and then we'll get 9 and 14, because 9 in the hexadecimal table is still 9, while 14 in the decimal is 14, but in the hexadecimal is E. Therefore, we can write it as 9E with the basis of 16. And this will be our final answer, because E in hexadecimal is 14, because 14 in hexadecimal is E. Therefore, this will be the final answer. Okay, so moving on to the fourth part, which is how to convert hexadecimal or hex to decimal. For example, we have 8bc to the basis with the basis of 16, because 16 is the basis of the hex, will be equal to the basis of 10, because 10 is the basis of decimal. What we need to do is we need to put the value of the hex, which is 8, b and c. B is actually 11 in hexadecimal, write it, and c is actually 12 in the hexadecimal. So, and then we need to times it with the basis of the hex, which is 16. And then we can put the power to the basis, and we can put it starting from the most right one, or the LSB. So the LSB will have to put the power to the basis, which is 0, starting from 0. So 0, 1, and 2. Therefore, we'll get 8 times 16 to the power of 2, which is 2048, plus 11 times 16, which is 176, plus 12 times 16 to the power of 0, which is 12 times 1, and then we'll get 12. And then the final answer will be 2236 with the basis of 10. This will be our final answer. Okay, so going on to the fifth part, which is binary to hexadecimal or hex. How to convert binary to hex. First, we have example, which is 1011 1000 1101 with the basis of 2, because it's binary, will be equal to point with the basis of 16, because it's hex. So how to do it is, if you convert binary to hex, then we will divide the bit into 4 value each. So we need to divide like this. Oops, wait, sorry, this was 1011, so we need to divide it to 4 value each. So this one, and this one. Okay, so and then we'll get 1011, which is equal to 1 plus 2 plus 8, which is 8 plus 2 plus 1 will be equal to 11, and in the hexadecimal 11 will be B, and then 1000, which is equal to 8, and 1101 which is equal to 8 plus 4 plus 1, which is equal to 13, but in hexadecimal 13 is D. Therefore we will have the answer, which is B8D with the basis of 16. This will be the final answer. Okay, so going on to the 6th part, which is how to convert from hexadecimal or hex to binary. So here we have 9C with basis of 16, which is the basis of hex, will be equal to point with the basis of 2, which is the basis of the binary. So what we need to do is we need to divide the value of hex, which is 9, and C. Well, C is actually 12 in decimal. So what we need to do is we need to write both 9 and 12 to the binary code. So as we know, 9 is 1001, while 12 is 1100. If you don't know how to do it, so let me explain it to you. So the first one here is we have 1 here, and then we can times this 1 times 2, because binary, to the power of 0. Then we will get 1, and then this one will be 0 times 2 to the power of 1, and then we will get 0, and then this will be 0 times 2 to the power of 2, which is 0, and this will be 1 times 2 to the power of 3, which is 8. And then we can add it, and then we will get 9. And here we have 0, and we can times 0 times 2 to the power of 0, which is 0, then we add 0 times 2 to the power of 1, which is 0, then we add 1 times 2 to the power of 2, which is 4, and then we add 1 times 2 to the power of 3, which is 8, and then we have 12. Then what you need to do is you just add the binary code, and then we will get 1001 1100. I'm sorry, I mean it's not to add it, but by combining it, and then this will be the final result with the basis of 2, because it is a binary code. Okay, so moving on to the 7th part, which is how to convert from decimal to octal. Okay, so for example, we have 796 with the basis of 10, because 10 is the basis of decimal, will be equal to point with the basis of 8, because 8 is the basis of the octal. So what we need to do here, we need to put the value of decimal, which is 796, and then we will divide it by the value of the basis of the octal, which is 8, and then divided by 8, then we will get 99 with the remains 4, and then we divide 99 with 8, and then we will get 12, the remains of 3, and we will divide 12 by 8, we'll get 1, and the remains of 4, then we'll divide 1 with 8, and we'll get 0 with the remains of 1. So basically we need to divide the value of the decimal with the basis of the octal, and then we keep the mode or the remains. So from here you can write it from the top or from the LSB, or you can write it from the bottom one or from the MSB. LSB is the least significant bit or the one on the most right, while MSB is the most significant bit or the one on the most left. So if you want to write it from the MSB, we will get 1, 4, 3, 4 with the basis of 8 because it's a octal. And this will be our final result. So moving on to the 8th part, which is from how to convert from octal to decimal. Okay, so we have 1945 with the basis of 8, because it's an octal, will be equal to point with the basis of 10 because it's a decimal. So how to do it is just like from the last one. We put the value of the octal, and then we will times it with the basis of the octal. So we can write it from the MSB. We have 1 times 8 plus 9 times 8 plus 4 times 8 plus 5 times 8, and then we can put the power to the basis starting from the LSB. So 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, and 8 to the power of 3. And then we will get here 512 plus 576 plus 8 times 4 is 32 plus 5 times 1 is 5. And then we will get 1125 with the basis of 10 because we are converting it to the decimal, and this will be the final result. Okay, so going on to the 9th part, the last but not least, how to convert from binary to the octal. Here we have, for example, 1 1 1 1 0 1 with the basis of 2 because it's binary, will be equal to point with the basis of 8. So unlike the hexadecimal, in hexadecimal we divide the bits of the binary into 4 value each, but here in octal we divide it into 3 value each. So this is what I mean. We divide it into 3 bits each. This. Therefore, we will have 1 1 1 and 1 0 1. So as we know, 1 1 1 will be equal to 7 because 1 times this 1 times 2 to the power of 0 will be 1, and this 1 times 2 to the power of 1 will be 2, and this 1 times 2 to the power of 2, which is 4, and then you add it, and then you will get 7. And here we have 1 times 2 to the power of 0, which is 1, 0 times 2 to the power of 1, which is 0, and 1 times 2 to the power of 2, which is 4. We add it, and then we have 5, and then we put it together. We will have 7 and 5 with the basis of 8. This will be the final result.